Look up at the sun, and it appears small, a bright disk you could cover with your thumb at arm's length. But that perception is a trick of distance. The sun sits about 149.6 million kilometers away from Earth, which makes its immense size seem manageable. In reality, the sun's diameter is about 1.39 million kilometers, roughly 109 times wider than Earth's 12,742-kilometer diameter. If placed side by side at true scale, more than 1.3 million Earths could fit inside the sun's volume. It contains about 99.8% of all the mass in the entire solar system, approximately 1.989 times 10 to the 30th kilograms, leaving every planet, moon, asteroid and comet to share the remaining fraction. Its gravity controls the orbits of objects billions of kilometers away, extending far beyond Pluto into the distant Oort cloud. At its core, temperatures reach about 15 million degrees Celsius, where nuclear fusion converts roughly 600 million tons of hydrogen into helium every second, releasing energy that takes thousands of years to reach the surface and just over 8 minutes to travel to Earth as sunlight. That light powers Earth's climate, oceans, and life itself. The sun does not merely sit in the sky. It dominates, sustains, and defines our solar system. Once its true scale is understood, daylight stops feeling ordinary and starts feeling astronomical. The sun's diameter is staggering. The sun's diameter measures about 1.39 million kilometers, while Earth's diameter is only about 12,742 kilometers. That means you could line up approximately 109 Earths side by side across the face of the sun, and that comparison reflects only its width. When volume is considered, the scale difference becomes even more staggering. Roughly 1.3 million Earths could fit inside the sun. Despite appearing as a small, manageable disk in our sky, this is purely an effect of distance. The sun sits about 149.6 million kilometers away. In reality, it is a colossal sphere of superheated plasma, composed primarily of hydrogen, about 74%, and helium, about 24%. Its surface temperature averages around 5,500 degrees Celsius, 9,900 degrees Fahrenheit, while its core reaches about 15 million degrees Celsius, where nuclear fusion converts hydrogen into helium and releases vast amounts of energy. That energy output is approximately 3.8 times 10 to the 26th watts every second, more power than humanity could generate in billions of years. When viewed to true scale, Earth becomes almost invisible beside it, a small rocky planet orbiting a star that utterly dwarfs it in size, mass, and energy. Over 1 million Earths could fit inside. When comparing volume instead of just diameter, the scale difference becomes almost incomprehensible. The sun's volume is so vast that approximately 1.3 million Earths could fit inside it. If it were possible to hollow out the sun and fill it with planets the size of Earth, they would stack inside like tiny marbles in a glowing sphere nearly 1.39 million kilometers wide. Earth, by contrast, spans just 12,742 kilometers in diameter. This enormous difference arises because volume increases with the cube of radius, meaning small changes in diameter translate into massive differences in total space. The sun's total volume is about 1.41 times 10 to the 27 cubic meters, compared to Earth's roughly 1.08 times 10 to the 21 cubic meters. Even that 1.3 million figure is an approximation, since both bodies are not perfect solid spheres, and Earth would not pack perfectly into every gap. The sun's immense size is matched by its mass, about 1.989 times 10 to the 30 kilograms, accounting for 99.8% of all the mass in the solar system. These numbers highlight a humbling reality. Our entire planet, with all its oceans, continents, and life, occupies only a tiny fraction of the space dominated by a single average-sized star. The Sun holds almost all the solar system's mass. The Sun contains approximately 99.8% of all the mass in the solar system, about 1.989 times 10 to the 30th kilograms, leaving less than 0.2% to be shared by every planet, moon, asteroid, comet, and speck of dust combined. Jupiter, the largest planet, holds most of that remaining fraction at about 1.9 times 10 to the 27th kilograms, accounting for more than twice the mass of all the other planets put together. Yet even Jupiter is minuscule compared to the Sun, possessing only about 1,000th of the Sun's mass. This staggering imbalance is the reason the Sun's gravity dominates the entire solar system. Its gravitational influence governs every planetary orbit, every comet trajectory, and every asteroid path, extending far beyond Pluto into the distant Oort cloud, nearly a light year away. The planets do not orbit because they choose to. They are bound by the curvature of space-time, created by the Sun's immense mass. Without it, the solar system would not exist as an organized structure. Every year on Earth, every season, every sunrise depends on the precise gravitational balance dictated by our star. The Sun is not just the brightest object in our sky. It is the central anchor holding an entire planetary system together. The Sun is 330,000 times more massive than Earth. Mass is not the same as size, and the difference becomes profound when comparing Earth to the Sun. While the Sun's diameter is about 109 times wider than Earth's, its mass is about 330,000 times greater, approximately 1.989 times 10 to the 30th kilograms, compared to Earth's 5.97 times 10 to the 24 kilograms. That enormous mass generates the gravitational force that keeps Earth in stable orbit at an average distance of about 149.6 million kilometers, or 1 astronomical unit. Earth travels around the Sun at roughly 30 kilometers per second, completing one orbit every 365.25 days, and this precise motion is entirely dictated by the Sun's gravitational pull. Without that immense gravity, Earth would not circle the Sun. It would move in a straight line into interstellar space, according to Newton's first law of motion. The Sun's mass also governs the orbits of every other planet, shapes the paths of comets, and stabilizes the overall structure of the solar system. This difference is not merely visual or conceptual. It defines the architecture of our entire cosmic neighborhood. The balance between Earth's forward motion and the Sun's gravitational pull is what creates a year, drives seasonal cycles, and ultimately makes life possible on our planet. Earth is just a pixel at scale. If the Sun were scaled down to the size of a large beach ball about 1 meter in diameter, Earth would shrink to roughly the size of a small peppercorn about 9 millimeters across, placed about 15 meters away, the proportional equivalent of the real 149.6 million kilometers that separate us. This scale model reflects the true ratio. The Sun's diameter is about 109 times wider than Earth's, and the distance between them is about 117 times the Sun's diameter. In this perspective, Earth is not just small, it is almost imperceptible compared to the central star it orbits. Yet on that tiny speck exist 8 billion people, oceans averaging 3.7 kilometers deep, mountain ranges stretching thousands of kilometers, and a biosphere that has evolved over 3.5 billion years. The Sun, containing 99.8% of the solar system's mass, dominates the structure and motion of everything around it, while Earth occupies only a minuscule fraction of the available space. This simple physical model makes the scale difference tangible: a bright sphere at one end of a field, and far away, a nearly invisible grain representing an entire world filled with life. The Sun is a nuclear furnace. The Sun's enormous size and mass create the extreme pressure and temperature needed to sustain nuclear fusion in its core. At temperatures of about 15 million degrees Celsius, and pressures more than 250 billion times Earth's atmospheric pressure, hydrogen nuclei collide and fuse into helium through the proton-proton chain reaction. Every second, the Sun converts roughly 600 million tons of hydrogen into helium. In that process, about 4 million tons of mass are not lost, but transformed directly into energy according to Einstein's equation, E cum mc. That mass to energy conversion produces approximately 3.8 times 10 to the 26 watts of power, an output so vast that in 1 second, the Sun emits more energy than humanity has generated in all of history. The energy created in the core does not escape immediately. It can take thousands to hundreds of thousands of years to slowly migrate outward through the Sun's dense interior before reaching the surface. Once released as sunlight, however, it travels the 149.6 million kilometers to Earth in just about 8 minutes and 20 seconds at the speed of light, 299,792 kilometers per second. The warmth you feel on your skin began as nuclear fusion deep inside a star 109 times wider than Earth, a constant reminder that daylight itself is the product of atomic reactions occurring at the heart of a massive sphere of plasma, dominating our solar system. Surface area beyond imagination. The Sun's surface area is about 12,000 times greater than Earth's. That vast area radiates enormous amounts of energy uniformly in all directions. Even though Earth receives only a tiny fraction of that energy, it's enough to power weather systems, ocean currents, photosynthesis, and life itself. We survive on a microscopic slice of the Sun's output. The Sun is an average star. Here's the humbling twist. Despite its overwhelming size compared to Earth, the Sun is considered an average-sized star, a G-type main sequence star. There are stars in our galaxy hundreds of times larger in diameter and some thousands of times more luminous. If Earth was small compared to the Sun itself is modest compared to giants like Betelgeuse or supergiants like UY Scuti. Gravity at the surface. If you could stand on the Sun's surface, which you can't because it's plasma, the gravity would be about 28 times stronger than Earth's gravity. A person weighing 70 kilograms on Earth would effectively weigh nearly 2,000 kilograms there. That immense gravitational force is a result of the Sun's massive size and density combined. It's a reminder that the Sun isn't just big, it's powerful, beyond human endurance. Earth survives at a perfect distance. Despite the Sun's enormous size and energy output, Earth orbits at a distance that allows liquid water to exist. This region is known as the habitable zone. If Earth were significantly closer, oceans could evaporate. Farther away, they could freeze. The balance between the Sun's size, brightness, and Earth's distance is what makes life possible. Our survival depends entirely on the scale difference between us and our star. The Sun looks small in the sky only because it sits about 149.6 million kilometers away, a distance that tricks our perception. In reality, it dwarfs Earth in every measurable way. Its diameter is about 1.39 million kilometers, roughly 109 times wider than our planet, and its volume is large enough to fit about 1.3 million Earths inside. In terms of mass, the Sun is about 330,000 times heavier than Earth and contains 99.8% of all the mass in the solar system, leaving every planet, moon, asteroid, and comet to share the remaining fraction. At its core, temperatures reach around 15 million degrees Celsius, where nuclear fusion converts about 600 million tons of hydrogen into helium every second, transforming roughly 4 million tons of mass into energy through EW-MEMSIC. That energy output equals about 3.8 times 10 to the 26th watts and travels across space at nearly 300,000 kilometers per second, reaching Earth in just over 8 minutes. We orbit a massive sphere of plasma, essentially a controlled, continuous nuclear reaction, yet from our distance it feels gentle enough to sustain oceans, weather, and life. Understanding the true scale of the Sun reshapes perspective. What appears small and ordinary is in fact a dominant cosmic engine anchoring our entire planetary system.